Okay, here I want to determine the difference quotient for the following. And what the difference quotient is a special instance when I need to find f of x plus h minus f of x all over h. And that looks very complicated, but it's not really if we are very careful in how we do this. Okay, so for part A, we have f of x equals x squared minus 5x. And the first thing we want to do is find f of x plus h. And if you remember, what that means is I need to replace, anytime I see x, instead of writing x, I need to write the value x plus h. So that's x plus h squared minus 5 times x plus h. And let's simplify that out a little bit. So that's going to be, if you square x plus h quantity squared, that's x squared plus xh plus another xh, right? You're foiling there, plus h times h, which is h squared. Okay, so again, what I did there was I said x plus h times x plus h. Okay, now I have a minus 5x minus 5h as well, because I got to distribute that negative 5. Okay, so when trying to clean this up, there's really not much to do, because you don't really have any like terms, right? You have x squared plus 2xh plus h squared minus 5x minus 5h. Nothing really simplifies there, so for the time being, we're done. It will clean up a little bit for us, though. Okay, so next we need to know f of x. Well, we already have f of x. That's just x squared minus 5x. So then now putting these together, we have f of x plus h minus f of x all over h. I'm going to pull in my pieces together. Let's see, for f of x plus h, I have x squared plus 2xh plus h squared minus 5x minus 5h. Okay, that's all my first expression. Then I have minus x squared minus 5x. Okay, and all that is over the expression h. My goodness, this looks really complicated, but then if you notice, I have an x squared minus an x squared, and I have a negative 5x minus a negative 5x. So some stuff canceled out, and now I'm left with 2xh plus h squared minus 5h all over h. And remember, if there's an h in every term, which there is here, I'm free now to cancel out an h out of everything. And I'm left with then 2x plus h. There's my difference quotient for the value x squared minus 5x. There's your difference quotient. Okay, now for B part, we're going to try this again. This time I need a g of x plus h at first. Okay, so again, that means I replace all my inputs with the value x plus h. So I end up with 1 over x plus h plus 2. Okay, now I also need g of x, which we already had, so there's nothing new there. So finally, to apply my difference quotient, which is going to be g of x plus h minus g of x all over h, I end up with, I'm going to write this a little bit differently, because remember, dividing by h is the same as multiplying by the reciprocal of h. So that's 1 over h times 1 over x plus h plus 2 minus 1 over x plus 2. Okay, so in this situation, I am going to have to do a little bit of work. I got to get a common denominator. So that's going to be, and let me make sure I'm keeping these separate, that's going to be 1 over h times, now for a common denominator, I need to multiply in, so this is like rational expression stuff. For the first term, I need to multiply in an x plus 2 over an x plus 2. So when I do that, my numerator is going to be x plus 2. My denominator is going to be the x plus h plus 2 times x plus 2. Okay, so all I did was multiply in x plus 2 over x plus 2. For my second term, I'm going to do a similar thing. I'm going to multiply in an x plus h plus 2. So I multiply that in the numerator and the denominator, and I end up with this expression. Okay, now when I'm really careful, I have 1 over h. Alright, let's think. I have an x minus x. I have a 2 minus 2. Since I have a common denominator, I can bring those together. And I'm left with a negative h over an x plus h plus 2 times x plus 2. And now notice, since this is all one term, my h in the numerator cancels with my denominator. So finally I'm left with negative 1 over that ugly denominator. X plus h plus 2 times x plus 2, which is actually not that bad. But there's my difference quotient. Okay, I want to show you one more. So let's look at part C here. This time I have k of y equals y cubed plus 2. Now remember, again, I got to replace the y's. That's my input. So if I want y plus h, for example, then I need y plus h quantity cubed plus 2. Now how do you do that? How do you handle that? That's y plus h times y plus h times y plus h. There's a factoring technique involving something called Pascal's triangle that will allow me to do this. And I actually have a video on that, and I'll have the link below. So if you need to use that, feel free to. When you cube this out, you're going to end up with y cubed plus 3y squared h plus 3yh squared plus h cubed, and then we have the plus 2 up front. And again, how did I do that? I had to use what we call Pascal's triangle. Will allow me to expand all that. Okay, now secondly, I need k of y, which is something we already had, which is the y cubed plus 2. So finally, when I want to do my difference quotient, which is k of y plus h minus k of y all over h, that's going to be this y cubed plus 3y squared h plus 3yh squared plus h cubed plus 2. All of that minus y cubed plus 2. And all of that's divided by h. Now notice here, I can combine like terms in my numerator. I have y cubed minus a y cubed, and I have a 2 minus a 2. So then finally I end up with 3y squared h plus 3yh squared plus h cubed all over h. And now every term also has an h in it, so I can cancel those out as well. And my difference quotient finally is 3y squared plus 3yh plus h squared. And there it is. Okay, so this all three of these involve some kind of tricky algebra, but once you have the algebra, the difference quotients are not too bad. Just takes a little work. I hope this makes sense. Please let me know if you have any questions on this. I'd be glad to help. And thanks for watching.